Tonight I will derive the Lorentz boost, which is this transformations of the space-times in the special relativity theory. So, the first of all, we know that the Galilean transformation in the classical mechanics, which is X primes, equal to the X minus VC, which is just a relativist velocity law for the each prime, which is last primes and the moving prime. And we want to obtain it some transformations for the X primes in the relativistic versions to satisfy the constant speed of the light, which is just the electromagnetism. And we want to satisfy the transformer satisfy the duality sign formalism for the inverse transforms, and there will be the sign factors of the k will be the multiply. So let's insert in the x in here, and we just given like that. So if we are on the answer of this formula in the t prime, then there will be the formula for the transformations for the t prime from the x and the t. And the goal is to bind up the k. And we know that the speed of the light is assigned for the each prime. So for the light is satisfied the x equal to the ct, also the moving prime. So we use up the such as assumptions of the special relativity theory. And just a moment, we know that the x is equal to the kx minus vt from this formula, so we insert that, and the t primes from this formula. So I mean t prime from the previous slides, and the only the such x prime equal to the ct is expressed only x and the t in the coordinates in the last prime. And if we rearrange the answer of this thing, all the x in the left hand side and all the t terms in the right hand side, and it should be the same to the x equal to ct. So such a factor x equal ct, so such a factor is should be equal to the 1. So from the numerator and denominator should be the same. And if we solve this thing, there will be the same terms, the k square c with will be disappears, and we can assign the k, which is 1 over the square root 1 minus v square over the c square, so called the Lorentz factor. And we will set that this is just 1 minus by the square root, where the beta is v over the c. The Lorentz boost is if we insert of the k's in the x prime and the t prime transformations of the x, and that's a linear, so it can be represented in the matrix. So such a Lorentz boost so represents resisting gamma minus beta gamma of diagonals and the gamma in the diagonal term. And it is in the previous videos we already discussed about was this Lorentz boost as a matrix representation. That is just rotations through the one space axis and the one time axis, and but the time axis has some imaginary time and imaginary triangle. So the axis rotation becomes the axis in the space-time diagram. So we derive the Lorentz boost. Yes, there are similar process x primes with the x and t prime, but with the t and x, and the register of the Lorentz boost is given like that. Yes, there will be the c. same dimension is with the space. And we know that there is a various phenomena of the spatial relativity is from the Lorentz boost. The first one is the relativity of the simultaneity. So for the last prime xt and the moving prime x prime t prime, in the moving prime, the light from the starting from the point O, and the light reaches the points A and B, the same distance, and that the times of the A will be the same in the moving prime, but in the last prime observer, light will be the reach I first, and after that to be at the which is at the base, the t i's and the t b's the last sign. So t bounds are not simultaneity, and we can express the relative simultaneity in this by some diagram. So in this, the last primes are x and t, and the moving prime t primes and primes will be constructed like that, and there are two events and a and b. And for the moving primes, it has the same t primes for the I and the b, but the different times for the last prime. And there's additional phenomena, which is time dilations and the space contractions. And there are some different behaviors for the last primes and the moving prime. So there are some of the derivations of the length contractions. There are some specific distance hours in the last prime. And for the moving prime start is observed by the R prime. So we can derive sort of the R primes is sort of Lorentz transformations. And we choose to insert in the x and the t, which is x is equal to the L, and t is equal to the v r over this cis keys. And for the in-base situations, when the objects, I mean, some distance is in the moving primes, and the last prime step observes the objects at such a distance. Then there will be the L's in the moving primes, and in the last prime, it will be observed by the R prime, and such R primes can be obtained by the gamma x plus beta gamma ct, because that's the inverse transformation, and which is insert and x and t, which is R and v are over the cis keys. Similarly, we can also derive the time dilations. The cluster in the moving primes, and the last prime step observers will observe such a clock. So some specific periods of the t in the moving primes, and it will be observed in the t primes and in the last prime. So ct primes are equal to the gamma ct minus the beta gamma x. And if we insert the t and x, and we can then the t prime. So we just the length contractions at the time relations is R equals to the gamma R primes, and the gamma is greater than the 1. So the observes the distance will be the contractions. The t primes are equal to the gamma t. The observes the times will be the light. So that's the phenomena of the spatial relativity theory. And I don't want to derive sort of the other relativist dynamics and the electromagnetism, which is the bulwarks, like the momentums, and also some field strengths, so the Maxwell's constances for the generalization versions of the Maxwell's equations, and but that's very important for particle physics and understanding Lagrange things. And then maybe the next time sort of the relativities and some coming cosmological, so we derive sort of the Einstein field equations and the solutions like the black holes distributions matrix and some this matrix and some Friedman's equation for the cosmology.